Learning AI is hard. Ask anyone that's been in the AI space for a while, and they'll probably just tell you attention is all you need. But it's definitely more than that. There's unnecessarily complex terminology, looking at you, Rag, and don't you need to have all that college maths you forgot about? AI is posed to be the greatest tutor humans have ever had. With infinite patience, the ability to teach in a multitude of styles, and with the proliferation of multimodal models coming out, learners are going to be able to learn in whatever method is best for them. Truly the golden age of education. But how do you use AI to learn about AI? Welcome to episode 36 of Tool Use, the weekly conversation about AI tools and strategies to empower forward-thinking minds, brought to you by Anetic. I'm Mike Bird, and this week we're joined by Dr. Stefania Druga, a research scientist at Google Gemini and the creator of the open-source learning platform Cognimates, which is teaching the future generation of AI engineers and scientists. Steph, welcome to Tool Use.
Thank you so much. Thanks for having me.
Absolutely. So you've done a lot with learning and helping spread the good word of AI, but can you give a little bit of your background, how you got to where you are today?
Sure. Yeah. So I started working in the space of teaching kids how AI works and using AI as part of their education process since 2015 when I was at MIT Media Lab. And I was actually part of the Scratch team, lifelong kindergarten lab. And before doing that, in 2012, I started my own NGO called Hackademia, teaching STEAM for kids around the world, like hands-on workshops where they would build robots and they could also program, but it was all focused on allowing young people, starting from 7 and up, to really learn through hands-on projects and be able to work on addressing challenges in their local communities, like anything for measuring like air quality, water quality, like have alternative solutions for electricity, but also like fun stuff like build their own video games or like make a banana piano. So that's sort of how I got started. And there's a personal motivation. I come from a small village in Transylvania, and it took a lot for me to, get to work at DeepMind or study at MIT. And I'm the first person in my family to go to, I'm first generation to go to college. So I'm realizing from my own experience how much like education has this equalizing force in society. That's what motivated me to invest a lot of time and effort into improving education.
Love that. Education is incredibly important. I did a little stint as a teacher, taught abroad back in the day. Wasn't a career path, but being able to just impart wisdom and generate excitement about things is wonderful. What type of barriers did you come across through some of your studies as to where people are and where they need to be in order to learn about this type of thing?
Yeah, so in 2015, the voice assistants were just becoming part of the home. So I basically was studying how the perception kids have of things like Alexa and Google Home and Siri influences the way they ask questions to these devices, and also influences how they perceive AI more broadly and other types of like AI technologies like smart toys and smart robots. And one of the barrier is that the initial perception really shapes how kids interact and learn with these technologies. So to give you an example, like if the discussion in the family or at school, or like if the kid attitude towards AI is like, it's really intelligent, it's much smarter than me, like I can ask it anything and it's going to give me the answer. They're not going to have enough of a critical understanding of when to trust or not to trust this technology. And also, they might not be encouraged to really try to understand how it works under the hood and open the black box, or how they could customize it and teach it and make it work for them, right? So that's really what motivated me to create Cognimates, to allow kids to open the black box and instead of saying this is magic, it's so intelligent, to really understand where the intelligence comes from and that it comes from people and that people train these models using data, that the data matters a lot. So they actually got to do this, right? So as part of Cognimates, there's a training section where they can train their own custom models with images and text and sensor data. And we did this back in 2015 when we didn't have large language models. And so they were using transfer learning under the hood and building classification models with more traditional machine learning. But they could definitely see an effect. So just by adding 10 examples of cats and 10 examples of dogs, like they could have a classifier that would distinguish between these two labels they created. but then also see when they added examples outside of the distribution, like a cat that was drawn by hand, that the model would struggle with it and kind of understand like, oh, I need to add that to my training data, and that's why it doesn't work. And also have more nuanced conversation around bias, right? Like, okay, I trained a model so I can play rock, paper, scissors, but it works for me, but it doesn't work for my friend because my friend has a different skin color. I know how to fix it. I'm gonna go back to my training and add pictures of my hand and my friend hand because kids really like want to be able to like play with their friends and care about these things. But like the approach of AI ethics and critical AI literacy needs to be playful to engage young people instead of saying, these models are biased, there's a lot of problems with them. That's very paralyzing for people. Like it doesn't give them agency to go and fix them, right? Or to really understand like why are they biased? Where is the bias coming from? And how can we address that?
Do adults have the same willingness to kind of dig in, understand how things work in order to gain that exposure to a deeper understanding of it? Or with kids' neuroplasticity, are they more prone to just be able to grasp something quickly?
Yeah, I think with kids is super fun because like whatever you put in front of them, like we did all of these workshops where they even had to like draw what's inside a voice assistant, draw what's inside Alexa, or like make a kit where they would design their own assistant, or like naturally they love to break things, and then like teaching them how to fix them is like a very powerful skill, but they're very good at breaking even Gemini chat or ChatGPT or any of the current, like they would think outside of the box and ask questions you don't expect or come up with examples that you don't expect. So they're very good at breaking technology, but then it's like teaching them how to engage in this cycle of break it, fix it, and kind of formulate hypotheses, test those hypotheses, and then kind of refine their understanding. So for that, like having a platform that provides the right level of abstraction, like what do you tinker with, is key, right? And this doesn't need to necessarily be like block programming language like Scratch. That's a good entry point because they all know it, so they don't feel intimidated. They're like, oh, I've seen this before. And now I can use these blocks to also program cameras and program robots and teach, voice assistants. But so it's not intimidating. It's a good entry point, but that's not always the right level of abstraction or heuristic. So, and I'll tell you about what are some things that I'm building now with multimodal AI and what level of abstraction I'm choosing for that. But I think for adults, like it really depends. So the pandemic was a good eye-opening for me because I had to go from working in person with kids around the world to actually doing everything online. And as you can imagine, it's pretty hard to do online, like hands-on workshops. So I really start working with families, right? Because kids were stuck at home. And throughout my PhD for 3 years, I worked with the same community of 20 families from 10 different states in United States. Very different backgrounds, very different levels of exposure to technology, also different ethnicities and different like I said, regions of the country. And for those 3 years, like it was eye-opening, like how important it is, like to engage the parents and engage the families. And I think it was the right timing too, because like the parents were disappointed with what's happening in school because they were exposed to how the kids were learning and what the kids were learning for maybe the first time to this extent. And then also they didn't know what to do with their kids at home. So they were eager to kind of like engage in learning activities and workshops. And so that was great. And I think that in the beginning, the parents were more skeptical and kind of less tinkering, but then they got inspired by the kids, right? So it was one of these like really cool partnership where the parents are there to kind of mentor and guide and make sure, like they help, like this is how you open a file and save a file, like more like the IT. But the kids definitely knew much more about AI and were more eager to kind of experiment and try. And the parents were taking a back seat and learning from their kids. So I actually wrote a paper analyzing all the roles that the kids and the parents take and how that changes depending on what they learn. But yeah, I think kids are an inspiration for adults, even for their parents or for their teachers, because I'm talking to a lot of teachers and they're seeing their students using all these tools. So kind of saying like, we're going to ban using Gemini, using ChatGPT is like the early days when they were banning Wikipedia. It's not going to work. So it's really about like how do we teach young people to use it mindfully, right? Like what's the transition from digital literacy, media literacy to generative AI literacy, and when to trust it, how to look at the sources, how to use it, what to delegate, what not to delegate, so we don't have underskilling, right? But yeah, I think adults are being inspired by how much and to which extent young people are using these technologies, and they're starting to tinker a bit more too.
Good. Yeah. It's if you can have the viewpoint of lifelong learning, it's a wonderful thing. I did a little stint at this company called Thunkable, which is no code mobile app development. It also uses a Scratch type block based coding. And it was really cool seeing people who are really technical being able to get into it. But what I'm curious about is if you've done any research into the children who just aren't interested in tinkering, building that type of thing, and developing their AI literacy. Is there any avenues that help them be sure that they're fully aware what's going on without that desire to tinker and get to the middle of it?
Yeah, it's a great question. So, a lot of the work that comes from lifelong kindergarten, and kind of this goes back to the tradition of Seymour Papert and constructionism, and it takes a more Socratic approach to learning. And that doesn't necessarily mean that you need to build things or tinker, but more that it builds on this philosophy that people will figure it out as long as they are supported to ask questions and kind of explore. Like we have a lot of wisdom in our priors and our intuitions and kind of like approaches, like our approaches to learning are the folk philosophies called, like, if you put a person in front of a river with a pile of rocks, eventually they'll figure out how to build a dam, right? Like that's the Socratic approach. And yeah, I think it all stems from what you're into, like what are your interests, right? So the reason Scratch became so popular is because it allowed people, like if you're into music, you're gonna build, like you're gonna create songs. If you're into animations, you're gonna make animations. If you're into fashion, you could do like whatever you're into, like you could it was like allowing you to express yourself through creative coding based on your interest. But it doesn't need to be coding, right? Like if you're like don't want to build anything, like you just want to, you're into literature or like you're into sports, you like to go and run outside, right? Like you could still, like in that context, use tools like to help you keep track of your throws, right? Or like I don't know, like coach you like when you're struggling at school because someone is bullying you. Or right now, like this technology is embedded in so many different aspects of young people's life, like their college applications, like the way they're being graded. You know, like I don't know if you've seen this, but last year, the teens took to the streets in UK to protest because an algorithm was being used for grading them, and the algorithm graded more harshly students coming from high schools in low SES neighborhoods based on the zip code. They were like, this is unfair. Like, we trust our teachers. You should, like respect our teachers. And they did like this massive protest in London, UK. So yeah, I think it's not only for people who want to build, but I do think that young people are using applications that have like AI filters for TikTok, right? Or like, well, they are using AI in so many shape and forms. So having support for inquiring, like, what data is this collecting? Am I getting the right answers? Like, do I understand what happens with that data? Like, what recommendations I'm gonna get based on what I click, right, on Instagram? So it's affecting their lives in a very, very tangible way. So I think this kind of AI literacy is for everyone, not only for people who like to build.
Staying on top of AI news shouldn't mean endless scrolling. Anetic Daily Intelligence is a free daily report uniquely curated just for you, like a personal assistant updating you on exactly the AI news you need. Every report is unique to each reader and continually adapts based on your feedback, keeping you ahead of the curve on the topics that matter to you. Sign up now at anetic.co. One thing you kind of touched on is just how people are directly influenced by it. And I'm curious about the degree of anthropomorphization around the AI and if that has an impact. Because in my mind, I see, the OpenAI's advanced voice modes, a blue dot that's kind of amorphous. It sounds real, but it's very clearly a robotic entity. But as we try to make it more like he, she, it, they, Is that influencing the way people either learn from AI or interact with AI?
Yes, and I've done a lot of research on, for example, when the voice assistants came out, there were lots of different voices. There was an assistant called Q that had a gender-neutral voice, and we asked kids to actually discuss this, right? Like, how does the voice change? How they trust it? How they interact? How do we design a voice for this type of assistants, right? And that's even more important for the powerful LLM assistants that we see now because they're much more believable than the voice assistants were in 2016, 2017. And I feel like there's two aspects to this that I want to talk about. One is that anthropomorphization is not always bad per se. And the fact that we do that is, evolutionary speaking, very logical because we had to make sense of the world based on references to us, right? And what we understood best. So it's human nature, like even when you look at a plug to see a face, like, and of course, like young people and elderly do it more and are kind of more prone to being deceived. But if technology design is kind of really honing in on manipulating like the human likeness, but anthropomorphizing as a human process of sense making is not negative. Like we actually do it in how we talk about things. Like we wrote a paper kind of creating a taxonomy and showing what are all the different ways in which people anthropomorphize, like when they talk about different AI technologies. And this was with adults. So it's with Emily Bender and Nana Inye. It was published at Fact last year. And it showed that from the verbs we use, like if we attribute like cognition, right, like to a car, self-driving car, like the car drives, right? Like that's already anthropomorphizing, right? Even when you say artificial intelligence, that's an anthropomorphic term because we don't say automatic probability, right? Or like we don't. So we assign intelligence to a machine, right? Like or to a system. So it's so embedded now in so many of the terms and expressions and ways we talk about these technologies. And yes, I think sometimes that sets the wrong expectation, but we need to realize that that's human natural tendency to do that. So I think that's this kind of my comment on anthropomorphization, which tends to always get a bad rep, and I don't think it should always get a bad rep. Now, when it comes to technology design, in my experience, and I got invited to kind of advise and evaluate on the Canamigo, tutor design, and a lot of these technologies for kids. And I've been studying like smart toys, and when they were trying to put like a voice on everything, Barbie had a voice, and like tools. I feel like a lot of times when we over anthropomorphize, it's very often used as a way of disguising limitations in the technology because it's kind of like a quick trick to say, look how appealing this is, and look how he talks like a human, and look like what a cool personality, and it's fun. And instead of actually like having that technology be reliable or like always provide the right answer or do what you expect it to do. So it's like, I don't want to, maybe calling it a cheap trick is too harsh, but it's definitely a trick that technology builders and designers use. And I don't think it always pays off, right? Because even if like these voices are really cool and like I like the animation and I like talking to it, at the end of the day, if it's not going to have the good answers or if it doesn't do what I expect it to do, like I'm not going to use it. Like, and the thing is, like, if you have very high anthropomorphization, it sets very high expectations. So it's easier to be disappointed when the technology does not meet those expectations.
Yep. One note on smart toys that you mentioned, it's just something I've heard from a couple of people, but I've been hearing that kids aren't as interested in the smart toys as just the more traditional dolls or action figures or whatever, because it almost takes their imagination, their imparted personality on it and forces one on them. Have you noticed anything like that?
Yes. And I actually taught two classes on smart toy design. One was at RISD in industrial design, and the other one was at ITP at NYU. It's kind of like interactive technologies degree at NYU. it was amazing because we did playathons. So the students, these were like design students or interaction technology students, master students. And they would design smart toys that made sense for kids. And we actually went to schools and tested them with kids and had kids come over and did like lots and lots of iterations. And the idea was like really to only add AI or technology if it made sense to the play experience and provide so many other examples that are not voice, right? And that didn't take away from the from the play experience, and that didn't take away from kids' imagination. It was kind of cool because the students had these ideas, of like they did like inflatable Legos, for example, with special molding and casting, or there was a musical box where you would hum a song and then it would on device or recognize the song, and then you would put different cards that can add different sound effects, and you would crank it, and you would play back that song, but with the effects of the card instruments. So these are the type of things, like, I think we really need to stimulate people creativity and imagination, and I do think technology can do that if used properly, right? And for that, we need to do iterative design with the kids, listen to what the kids like, and see how they play. My students, like, I remember like the first quick and dirty prototypes, like when the kids came in and start playing, how they were like mind blown because the kids would always do things they didn't expected. The thing that they thought like, oh, that's the coolest feature, like they would be ignored, right? So they quickly learn like, I'm not designing for myself, right? Like, I think a lot of the people in the AI space today make this mistake where they're designing for themselves and they think they know their user. And actually, like the way things were when I was a kid are very, very different than the way things are for kids today, right? So I cannot use my experience as a reference. So I really need to understand how this generation of young people like to play and like to interact with toys and then design for that. But yes, I think in general, one trend we've been seeing, which is worrisome, is that they do spend much more time on tablet and YouTube and media consumption. And if you think about it, going back to like to tinker or not to tinker, right? Like a tablet doesn't have a keyboard. It doesn't allow you to input things easily. It's more like a design that was made for consumption versus a laptop, which is more a device where you could actually create. But yeah, the trends we were seeing, and this was in 2018, right? Like when I taught in this class and the students build these toys, many of them are actually ended up like being published. And I think it's one team that went and built a company. And but yeah, like from 2018 until now, like we were already seeing like trends that they prefer to spend time on tablets and YouTube or just consume media and play less with toys. My prediction is that it's only gotten worse and that I haven't checked the stats of toy sales, but I do think that unfortunately children don't play as much anymore, which is a shame.
Yeah, I mean, I remember growing up with Lego and playing road hockey and all these things, and you just don't see it as much anymore. And I mean, things coming out like Minecraft can give you that like builder sensation, but you're still interacting just with the screen. Even if it's not just for kids in general, do you have any advice or principles for building tools that genuinely augment creativity rather than just like force you into a certain path?
Yeah. I thought about this a lot recently because I'll give you an example that directly impacted me. I'm learning Japanese. I'm in Tokyo right now. Behind me is like, so
Love Tokyo.
it's a hard language, right? And I've been trying very hard. And of course, I'm using AI, and I use it like I use Suno to generate like rap songs with references to Romanian and Japanese, and I listen to those in the subway, and that's kind of how I hype myself to stay motivated learning the language. And of course, I'm taking classes with people in person, and that's amazing. And but when I write, right, like I think a lot by writing, and I notice that when I write on paper versus when I write on a tablet or any digital device, I don't retain information the same way, which is kind of crazy, right? Like I retain information much better when I write on paper. It's just like even that pressure of like how much effort I need to put on the pencil like to write on paper versus a digital device, because that's again evolutionary, right? Like, and even the fact of writing per se, like let's take us away for now, like digital or non-digital, like writing. So for me, I'm building these new tools and interactions to support kids learning, and I'm constantly thinking like, what is the natural workflow that where they would learn the most, and how can I bring the technology there rather than taking them away from that workflow and bringing everything on a device, right? So I'll give you two concrete examples. One is I call it MathMind. So a tool I recently built. It allows kids to just solve math on paper, and you can put a webcam anywhere, or you could use your phone. Just point at your paper, and in real time, like I'm solving there in real time, it's gonna ask me questions, and it uses a model that actually has a reference to a benchmark of 55 most common misconceptions that kids do in algebra in middle school. So if it sees that like I have one of those misconceptions, like I don't know how to work with fractions yet, or like the order of operations, or like, there's lots of these kind of common mistakes. It's going to ask me questions to highlight the fact that like I don't understand. It's not just the mistake that I'm making in this example, but that I don't understand the principle. Maybe suggest an exercise where I can practice until I get the principle. So that's like kind of like working on paper in real time. So it's streaming and just asking me questions to debug my thinking about math. But like all I'm doing, I'm not changing anything, right? Like I'm just solving math on paper. And I'm kind of working through, and I have like this interactive debugging duck that can ask me questions about my math, right? That's one example. The other one is in chemistry, right? So I'm realizing like with multimodal, there's like all of this world of opportunities that go away from the devices, right? So we can act like in the real world. So if I want to do like experiments, all of a sudden now like I can have my experiment bench and have sensors that are connected. I'm using JackDack, which is building on Microbit is the cheapest board that most of the schools have, most of the kids have. It's like, I don't know how many, $15 now. And then you can plug and play any type of sensor. So in real time, it's going to measure like temperature or light or CO2. And then I can kind of put on the table like things I have at home, right? And be like, oh, what can I do with this? Like, what experiment can I do with this? Or like if I mix this and this, and in real time, it's going to read the sensor data and be like, oh, what did you expect, right? Like, or do you need more heat? Or what is your solution going to look like if you add this, right? And it integrates with the webcam. And the cool thing is that the webcam can become a microscope, right? So like any webcam, if you flip the lens, it amplifies the image much more. And then all of a sudden I can look at like, oh, like I can look at what's in my food or what's in water from the tap, or so these are like, I hope these two examples highlight how I'm thinking about like meeting people where they're at. And this is not just for kids, right? Like it's like, what's your workflow? Where do you work? What are the things that you manipulate and kind of naturally interact with? And how can you bring the technology support in situ in real time and make it seamless, like so you don't have to go and type somewhere or like take pictures and upload, or like so it doesn't break your flow and it doesn't take you out of the zone, right? And I think that's a really good principle in general. Like if I like to write in, I don't know, like a local in Word or Docs or whatever it is, like I want everything to happen there, right? Or if I work with Photoshop and I invested years to learn how Photoshop works, like that's where I want my support, right? So yeah, I think this is a good principle of like supporting real-time interaction in situ and allowing people to focus on their workflow without having to worry about going and communicating with a side AI assistant.
Brilliant. Yeah, reducing the friction, bringing it to where the user's at, super important principles. It also, though, dangerously approaches the point of abstracting away the decision making from the user and just having something be like a set of rails that the user just gets on it and is pursued through. Do you have any principles or guidelines for when you build AI applications to ensure that the user's still in control and it's just having the AI poke and prod them in the right direction rather than like steer them completely there?
Yeah, 100%. So these two examples, like both the chemistry, kind of the chem body, it's called chem body, and the math mind, they never give you solutions. They ask you questions, right? So they're extremely Socratic. And it's just like, okay, let's try to take another picture. Like, oh, what do you think would happen here? Like, let's write down like your prediction, write down your observation. Let's look at it. What if you did this and that? What do you think will happen next? Right? So I think the art of teaching is actually asking good questions. Like and this is how I teach, by the way. And I also taught like in high school, and like it's like I ask a ton of questions. And yes, of course, if you're really stuck, like, and it's actually programmed this way, like if you ask the same question 3 times and you really don't know, like it's gonna help you. But the goal in what I do at least is like to make these technologies be kind of like supporting with your thinking and like tools for thought, rather than giving you solutions. And I think a way of kind of focusing and honing on the user and their agency is to have more efforts like this misconception example, right? Like if we really understand what are all the possible mistakes that a human can make in a particular task or in a particular domain, then the LLM or the mixture, whatever architecture we want to use, but the AI is going to be able to support the human better because it's going to understand like this is the type of mistake that the person is doing, or this is the potential kind of avenue in which they're going, and this is the type of question I can ask them. So it constrains like the support space to like known kind of learning scenarios, which is what a good teacher does, right? Like if you taught the subject for a while, like you sort of know, like, oh, at this point, like most of the people are going to make this mistake, right? Or this is a common misconception. And you're kind of like designing your teaching strategy for that. So I think we can do the same with AI, but this requires us to really understand the design space, the learning space, to really understand kind of like in a task, in a domain, and it's very domain specific, like what are all the ways in which things could go wrong and what are all the common mistakes that people do. And the other thing is like allow the users to customize some of this, like allow them to enter a system prompt, or allow them to kind of control. Like a lot of the kids in the Scratch Copilot I built wanted to be like, I always wanted to give me 3 ideas, not 1 idea, like if it generates characters or names for things, or I always wanted to give me like 5 images, or so people could actually customize, right? Like what type of support and how much they want the AI to give them or not.
Very cool. Based on the research and what you've seen compared to the tools that exist in industry today, what is your assumption as to like some misconceptions people have in building AI tools versus what would lead to a better outcome?
I see a lot of people spending tremendous amount of time on benchmarks like eval scores and like LMSIS and like picking the best model. When I think the real like difference in the most lovable product, and we keep talking about MVP, minimal viable prototype, instead of minimal viable lovable, right? Like, or like what's the core interaction or the core value proposition that you want to have for your users. And very often you're going to get there through UI, UX, and really understanding like the interaction, right? And oftentimes it's not so much about using a more performant model, like by, I don't know, 20% better. It's really like the amount of time you spend on like designing the UI, UX and the interaction and how you collect the feedback from the users and kind of plug that feedback back into your application design. And I think I would love to see more people really honing in on how to collect feedback from people, and not in an annoying way. Maybe it's just like based on what they click, right? Or like based on how much time they spend on a task. Or in human computer interaction, these are techniques that are well understood and have been studied for so long. but kind of use those techniques in these new generative AI tools and applications, and really improve the experience, the user experience, the interaction and the user experience, versus of focusing on kind of vanilla industry benchmarks and maybe generate like specific tasks benchmarks based on what people ask, right? Like if you see, okay, like in my Scratch Copilot, like a lot of the kids are asking this question and they're asking it in this like weird way, like make the dude walk, right? Like who's the dude? How do we make it walk? And then I need to create a benchmark that is specific for my use case, right? For my application. And when I make decisions of both the model, but also like the prompts or whatever, like database searches it does, or like kind of aesthetics of the artifacts it generates, like I need to run that benchmarks against like what the users in real time on my platform do and prefer. So I think we're gonna see a lot more efforts into this pipeline from interaction to custom benchmark and iterating on that cycle much faster, because that's going to lead to better product experience. And I think the real differentiator is the product experience.
Yep, I fully agree. And I've heard from some people that of the startups that exist today in the AI space, about 10 to 15% have their own eval set. Most don't. Do you have any advice on whether it's for like a personal project or academia or for industry, setting up an eval set to help with that iterative loop? Do you have any tips or tricks?
Yeah, I know there's a lot of frameworks that are currently being developed. And my preference is to, as much as possible, use real data instead of synthetic data. And I know that people like use LLM as a judge because it's like easy, and you can still have that into the loop and can be helpful. It would help you like maybe find certain bugs or certain issues. But there's no way of going around like having a spreadsheet with 30 golden examples that you really understand, and that's your real baseline, right? So my advice for everyone, it's not so much about what technology or framework they're using, but like take the time to create a spreadsheet with 30 examples that should always work, and make sure you always evaluate your system against those. Like,
yep, look at your data, as they say. I'd be keen on getting some of your insights on just the state of what the state of the art is. Do you have any examples of using Gen AI for physical creative endeavors? That the example you gave with chemistry was wonderful, being able to take in the sensor down and whatnot. But anything else in the physical world that you think is cutting edge and really innovative?
yeah, so there's so many. One that I love is in smell. So there's this company, I forgot what it's called right now, but I can look it up. But I remember they allow you to customize perfumes. So you sort of describe what you like, or you take pictures, like, I have these flowers next to me, and it's like, these are my favorite colors, and like, I take a picture of that, or like a landscape I like, or maybe how I'm dressed. And then I can even add a song, like this is my favorite song. And based on all of that and a prompt, it would generate a fragrance that is customized to me. And then they can ship it to me. So I love now that, like with synthetic biology and like all of this work, the research done in synbio space, you could customize fragrances and get like your customized perfume. So that's one example that comes to mind. Trying to think in the physical space. I'm using, of course, like for running and sports, like I really like to have like custom notification based on my exercise goals or my heart rate or any of the kind of fitness tracking and support with fitness tracking. Trying to think, robotics is huge, so I guess that qualifies for the physical space. Hunting Face just had their first like AI and robotics hackathon in Paris, and it was huge. And I love they're using like this open source 3D printed robot. And when I start playing with robots, I had a 3D printed open source robot on top of Raspberry Pi, which is also from a French lab. It's called Ergo Robot, and it looks like the Pixar lamp, and it was like a joy to play with. So yeah, I think like anything in the robotic space right now is really being disrupted. Because again, we have better multimodal, like better vision models combined with code generation, combined with text, combined. So you could close the loop for supervised learning for robotics much faster. I love this is more like, I don't know if I would, but like at the AI Engineering Summit, the last one in SF, there was a robot barista, and it was pretty awesome. Yeah, I think these are the top of mind examples. I'm sure there are others, but that's the
Oh
first
yeah,
thing that comes to
the
mind.
whole space is exploding. There's some all over.
Yeah.
But along the same vein, how about multimodal? I know that you're involved with that, and the apps are just starting to pop up, and it's really cool. Are there any that you think people should check out?
So I was actually looking at examples for video editing, and I think there are a few that are like popping up. What's this one? Wondershare, Filmora is one that I've been playing with, and let me open. Like I was actually just talking to these people on Twitter. There's one that is kind of like Cursor for video editing. Yeah, I think in the space of like just co-creation for video, for images, PowerPoints. Gamma just released like a new version. Like this is kind of for PowerPoint, like sleek presentation design, which I think is pretty cool. Cursor for video editing. It's called Ponder Studio AI. And yeah, I think like in general, like any sort of suite for creator tools, like of course, like podcast support, and I really like Notebook LM. I don't know if you play with it, and this is from Google, and that's not why I'm thinking, but I really like the fact that, there's so many papers that I need to keep up with, and I love that I can just copy paste papers, generate a podcast that I can listen to while I go in to the gym or go in do a run, or like I'm commuting to work. And now they have a feature that allows you to generate mind maps, and I really like that feature. So I love mind maps. So that's another one that comes to mind. A lot of things in music. I talked about Suno earlier. Like I've seen a plethora of like co-creation with AI for music. It's an exciting time. I feel like a kid again myself, because like every time I think of something, like I'm like, oh, I'm sure someone has built this, and like you go in, and it's so much easier now, like to kind of prototype and play and really like go from idea to prototype in a couple of hours, right? So it's we live in exciting times.
Yep. Never been a better time to be a curious person who has access to a computer. I live about an hour away from everything, so Notebook LM changed my life, because instead of just having something narrated or transcribed, being able to have it in a conversational tone, wonderful. I did introduce my dad to Suno, so every special event now comes with a song, which is a lot of fun. But last one for me. If you could implant one core principle about human AI interaction to the mind of every AI entrepreneur, what would it be?
Observe how your users play with your tool. There's no replacement for that. Like when I used to do a lot of research, or even like I work with Fixie, and I remember like I sat down our engineering team, and I showed them videos of people using the tool. And there's no replacement for that. I mean, it doesn't need to take a long time. And these are not like your colleagues or friends, like just like your target users or people who you never talked to before and who are not part of the tech bubble. Like if you're designing for them, just like early on, send them prototype and observe without interfering, without explaining how they use your tool. There's no replacement for that. And you're gonna learn so much. And I think like iterating fast on this principle goes a long way.
Absolutely right. Steph, this was a blast. Learned a ton. Really appreciate you coming on. Before we let you go, is there anything you want the audience to know?
I'm curious what you're building. Feel free to share and send it to me on Twitter or LinkedIn. And yeah, thanks so much for inviting me and for all the thoughtful questions.
Absolutely. Yeah, we'll link everything down below, but look forward to talk to you soon.
Take care.